We're going to draw aniline sideways. Our quick benzene ring technique was one on the top, and then we just draw two on the side real quick. Remember, kids, the more you do this, you'll develop your own technique. We can connect them all. We can put lines in between them all. But when we know it's a benzene, there's only going to be one bond on it. And that's what we look for. So the NH2 is just going to be our typical. We got to do right angle, though. Got to remember this now. We got to stick to the right angle on the nitrogen. We're not doing the triangle anymore. Right angle has a 90 degree in there. The 120 degree on the boron and the aluminum, because that's really the geometric space that it takes up. So there we go. This is simple now, right? We can pick any two we want for the double bonds. Let's see, how are we going here? Either way, we're going to get one in there. So let's go here, like double, single, double, single, double. So that's our benzene ring with a circle in there. Do that so it touches all the carbons. What was our brilliant idea? We came up with the yellow for the double bonds. It's the best thing for old highlighters when the ones work all cruddy. This is a yellow pencil. Look how good that comes out on the camera. We'll use our highlighter here, really highlight it up. And this really makes it easy to see these double bonds. I was looking at some molecules before, and especially when you get into your big chlorophylls and stuff. And that's because they're biologists. I'm going to knock you biologists. They're like, oh, well, that's chemistry. We're not concerned with that. So what do we got here? One bond on each of these, remember? It's a colored pencil 1, colored pencil 1, colored pencil 1. We're going to have one on those because there's got to be one. That's one we should have colored it on the inside. But what I want you to do is come up with your own way of doing this, because remember, it's a 3D molecule. So I want you to get a feel for that. When you start doing shading and you're going to color one line dark one time and think you made a mistake, and then you look and it'll look like it's going back in space. It'll look cool. So the more you do this, the more you're making it your own. This isn't a technique where you learn everything that I'm teaching you here. I'm showing you how we're making it up as we go along. And that's what you're going to do. And you're going to come up with your own new way of doing it. Oh, look, I colored the diamond instead of the double bond there, huh? This is why I say, too, you go back and you're double and triple checking yourself. First, we check the hydrogens when we go and we put the proton dot on. Then we go, first we draw it when we draw the carbon triangle. In case no one's ever looked at this before. These are the carbon diamonds. That's one. Carbon, carbon, carbon. That's the nitrogen. And what's nitrogen got? Lone pair of electrons, so we can put that alien wherever we want. We'll put it right here, I guess. So this is an aniline dye. Revolutionized the chemical industry. Started it rolling. Dude comes up with it on his Easter break. I'm sure he thanked God for that one. So we're going to have to take a break, go sharpen our pencils here. Is the black going to work? So now you finally go in and color in the carbons. Actually, we're developing a carbon coloring system, which I just ruined here. Black crayons. Everything we're using is recycled material here, kids, too, so I hope you appreciate that. These are, you're watching these as these were created for the first time. This is the first SchroederDiamonds technique to ever be used to draw the molecule aniline. So So when you see it all neat in a book like a computer did it, you remember where we started. Using recycled paper, recycled crayons, recycled markers, recycled pencils. I did buy these new markers because the old ones were worn out, but these pencils I have all found in the dumpster. Behind this, one of those things that calls itself a church. It doesn't have a priest. It's got some other guy that thinks he's holier than thou. So I thank God for them. I'm very religious. I pray every day for God to protect me from his followers. Blue. So again, kids, do what you like. Mix it up, too. Use pencils, use your markers, use your crayons, whatever it takes. Remember, these molecules are alive, so just staying inside the line you go outside is what it really looks like. This nitrogen is vibrating and moving around. So here's aniline. That almost looks like a fish, doesn't it, with the nitrogen tail on there? Huh? How's that look? Anything to make it look colorful. Anything to help you remember it. Anything to get more descriptive. When you look at this now, remember, it's electrons is where all the stuff's happening. So you see a lone pair of electrons out here. What's that going to do to the water? See, here's our quiz again. We're going to just color in the O's, and we're going to make you pick where the hydrogens go. This is a little test idea that we came up with. We color the green dots, which are oxygens, right? You come by, and where do you put? Use the markers. Would the protons be attracted to the negative electrons here? Yes. You can see that very well. There we go here. So right here, see the protons are attracted to the electron pair. Over here, way outside here, we can see a water with a proton. So what part would be attracted to that? The negatives. So the ears would be pointing the other way. Over here, this is the fatty, oily loving part of this. So water is going to be repelled that way. Down here's one. So it'd be easier to picture this as the electrons having little hands grabbing, but for this part, you put where the hydrogens are. So protons are always opposed to themselves. Just like magnets, kids. This is exactly what magnets were like. You play with magnets, you're a chemist. It was Einstein's uncle who brought him a compass when he was sick in bed. That's what had him thinking about the whole gravity of the Earth inside the universe, inside the galaxy inside the universe. See, those are just words describing words. We know what we're seeing. We know where we are.